So, now let us see how the firms are going to behave. So, firm 1 revenue is equal to P times Q1. So, I can write this as P is equal to 100 minus Q1 minus Q2 times Q1. So, then let me expand this, it will become 100 Q1 minus Q1 square minus Q2 Q1. So, what should I do? I should take the derivative. So, the first order conditions will say that 100 minus 2 Q1 minus Q2 should be equal to 0. I want to write this in terms of Q1. So, I can write 100 minus Q2 is equal to 2 Q1 or 100 minus Q2 by 2 is equal to Q1, right. 100 minus Q2 divided by 2 is equal to Q1. You can figure out that for every level of Q2, what should be the profit maximizing level of Q1. If I knew this is how much that guy is bringing to the market, then I would say I would bring this much. So, if Q2 is equal to 80, 100 minus 80 is 20 divided by 2, then I would sell 10. And then of course, you can do the same thing with firm 2. You will say Q2 is equal to 100 minus Q1 by 2. Go through the same process with firm 2 and you will get exactly the same thing. So, then let me try and put this together. So, let me draw a diagram of this. Let me put Q1 here and Q2 here. So, when Q2 is 0, what is Q1? 100 minus 0 by 2 is 50. So, when Q2 is 0, then Q1 is equal to 50. Q2 is 0, Q1 is equal to 50. And when will Q1 be equal to 0? When Q2 is equal to 100. So, 100 say. So, when its Q2 is 100, Q1 is 0. So, I will join up these 2 points and I will get Q1 as a function of Q2. Now, we can do the other way around, Q2 as a function of Q1. So, when Q1 is equal to 0, Q2 will be equal to 50 just like before. So, 50 and this will be 100. So, I can join these 2 points up. So, and this will be R2 of Q1. So, these functions are called reaction functions. This tells you as it is like you are reacting to what the other guy is doing. So, as Q2 changes, what Q1 should be, and as Q1 changes, what Q2 ought to be. So, is there some point where both will be happy? At this point, what is going to happen is that firm 1 will say that whatever Q2 is producing, I am happy producing Q1, and the other way around, whatever Q1 is producing, firm 2 will be happy with that. It is like your equilibrium in demand and supply. You have plans, and that at that point both the guys' plans are satisfied. So, you are both like you do not want to move away from here. This is about the best you can do. And one way of thinking about equilibrium, when are you in equilibrium? When you do not wish to move. So, we can plug this here, right. We can say, so 100 minus Q1. So, this equation and this equation have to be solved simultaneously. But we know, right, that Q1 must be equal to Q2 because everything else is symmetric in this particular case, not always. So, therefore, Q2 will be equal to 100 minus Q2 by 2, or you can say 3 Q2 is equal to 100, or Q2 will be 100 by 3. will be equal to Q 1. So, both firms will now produce. What will be the output? Each will produce 1/3 of the market, essentially 100 by 3. Total output will be 200 by 3, 66, 67. So, what is happening? If you think about the demand and supply curve, if this is your quantity, here is your price, then the total amount that they are bringing to the market is about 67, sorry, should put here 67. And what will be the price? 100 minus 67, so the price will be around 33. So, what they are doing? They are not selling too much. They are both restricting the amount that they bring to the market to make sure that the price is high enough. And in fact, in both of these cases, you can find out the profits will be P 1 33 into 33, right, price times quantity. So, both firms would be making profits. So, which is in complete contrast to what we did with the Bertrand computation, where firms did not make any profit, but here suddenly firms are making profits.